So types of lightning arrestors. So these are the different types of lightning arrestors. Overhead earthwire, rod gap, and multiple gap arrestors, horn gap arrestors, expulsion type arrestors, and valve type arrestors. These are the different types of lightning arrestors. Okay, to provide the protection against lightning, these are the different types of lightning arrestors are used. Okay, so in this, so these are the different types of methods for protection against lightning. First one is called overhead earthwire and the lightning arrestor and surge diverter. Okay, and rod gap arrestors and on gap arrestors. By using these protecting devices, we have to protect our electrical operators against lightning. Fine. So these are the different types of three methods. Generally, these are the three methods we have to use for protection against lightning. Okay, protection against lightning. Generally, these are the three concepts we have to use. First one is called overhead earthwire. Second one, lightning arrestor and surge diverter. And finally, rod gap arrestor and horn gap arrestor. So these are the three different types of concepts we have to discuss. This lightning arrestor and surge diverter was explained in last class. So today we have to concentrating on overhead earthwire and rod gap arrestor and horn gap arrestor. Rod gap arrestor or horn gap arrestor or overhead earthwire. So simple concept for overhead earthwire. This is the overhead earthwire. This is called transmission system. Okay, so one of the transmission system in this transmission system, these are the different types of insulators, suspension type insulators. Okay, to provide the protection against lightning, we required one overhead earthwire. It's called overhead earthwire. So this is called overhead earthwire. On top of the transmission line is called overhead earthwire. Here, this line is called overhead earthwire in the transmission line. Fine. So if any lightning takes place on the transmission line, first the lightning is falling on this line. Okay, this line overhead top most wire in a transmission line. Okay, if any lightning takes place, first falling on lightning on the overhead earthwire, and then use amount of current discharging through transmitting tower to the ground. Power transmission tower to ground. Okay, this is a simple concept for earthwire. And the next rod gap arrestor. This is called rod gap arrestors here. This is called rod gap. So this is called one of the insulator transformer bushing. Transformer bushings. So to protect the transformer bushings against lightning, so the rod gap arrestors used here. This is called transmission line, and this is called rod gap connected like this. One end of the rod gap is connected to the transmission line, and another is connected to the ground. This is called rod connected to the ground. This is called rod connected to the ground, and this is called rod gap. And this distance between the insulator and rod gap. Okay, this is the transformer tank. On the transformer tank, there is a transformer bushings. Okay, so to provide the transformer bushings, we need rod gap arrestors against lightning protection. Okay, so here we have to maintain some distance here. If any lightning takes place on this transmission line, okay, and then this gap will be spark, and then the discharge to the ground in this way. Okay, if any lightning takes place on transmission line, okay, so then the fault current, that is heavy current, lightning current passing through the ground in this way. Under normal condition, it is acting as an open circuit. Under fault condition, there is a spark appear in between the two rods. Fine. So one rod is connected to the line circuit. One side of the rod is connected to the line circuit of transmission, and another rod is connected to the earth like this. Another rod is connected to the earth. Okay, the distance between the gap and insulator, that is called P, the distance between the here two gap, this gap and insulator, that is called P. The distance between the gap and insulator P, that is distance P, must not be less than the 1/3 of the gap length, so that the arc may not reach the insulator and damage it. Okay, these are the conditions we have to follow. Okay, the distance between the gap and the insulator must not be less than the 1/3 of the gap length, so that the arc may not be reached and the insulator and the damage. Okay, generally the gap length, generally this gap length is adjusted so that breakdown should occur at 80% of spark over voltage in order to avoid cascading of very steep wave front across the insulators. Okay, under normal operating condition, just like a is open circuit. Under normal operating condition, the gap remains non-conducting. Okay, under lightning condition or under fault condition, lightning condition, one of the occurrence of high voltage surge on the line, the gap will become spark. Okay, and the surge current conducted to the earth. If any surge takes place in the transmission line, and then the gap will become spark, and it will be acting as a conductor, and then the huge current diverted to the earth like this. Okay, this is about rod gap arrestors. Okay, after surge is over, the arc is and the gap is maintained by the normal supply voltage, leading to short circuit on the system. Okay, so next, the rod may melt or get damaged due to excessive heat produced by the arc. So this rod may be damaged or melt because of excessive heat in this between these two. Okay, this is one of the drawback of this rod gap arrestor. The climatic conditions also affect on the rod gap arrestor performance. It's clear. There are climatic conditions, example rain, humidity, temperature, affect the performance of the rod gap arrestor. Okay, and the polarity of the surge also affect the performance of the arrestor. So these are the some drawbacks of this rod gap arrestor. Okay,